Good evening, students. My name is Chandan Ghosh, and welcome to my math class, Mathematics. This is continuation to what we discussed in our previous class. In our last class, we have discussed about uh, permutations, some of the examples we showed where we should use permutations, and also we have derived the formula of permutation. Today, we will be discussing about combination. Let's start. So, combination is basically it's denoted as n choose r, which is n factorial divided by r factorial times n minus r factorial. And what exactly combination? Combination is the number of ways to choose r distinct objects from a set of n distinct objects. So the condition over here are always less than equals to n. So you must be interested the way we derive uh, the the formula of permutation in our previous class. You must be interested, curious, knowing how we can derive this as well, NCR. So in today's class, we will be, we will show you some example through which we will derive how we came up with this formula. Before that, one thing to remember, unlike permutations, in permutation, what it's a choose and arrangement, whereas combination is just choose. So let's you know just write down some of the differences between permutations and combinations. So permutation and so the first difference is it's a choose times arrangement. And in combination, it's choose only. Second difference, order matters. Here, order doesn't matter. So let's take an example. Say I do have 22 cricket players and I need to form a team of 11 players. So what should we do? The first problem is basically I need to form a cricket team of 11 members from 22 odd players. So it would be simply 22 choose 11. Now the second problem is I need to form a 11 member team, but I need to arrange them in batting order. Then it's going to be a permutation problem. P I P 11. Why this is? Because in the second case, we have to choose at the same time you have to arrange them in batting order. Hope you got the differences between permutation and combination. Let's move on to the derivation. How we came up with this one. NCR calls to n factorial upon r factorial times n minus r factorial. So we'll derive that. Let's take an example. I have 5 different letters A, B, C, D, and E. And I need to form 3-letter words. So how many 3-letter, how many 3-letter words can be formed? So that's my problem. So, you know, it's simply a permutation problem because first I need to choose 3 from the 5 and then I have to arrange. So let's see how many different choice set I can make out of this. So since I need to form 3-letter word, what are the different choice set I have? Let's say A, B, and C is my first choice. Likewise, it could be B, C, D, let's say C, D, E, and so on. I need to find the number of choices. So that is nothing but combination. Choose a distinct object from a set of n distinct objects. So these are the choices I have. In the first choice set, I have 3 letters A, B, C, in the second B, C, D, and so on and so forth. Now, how many different ways I can arrange ABC? See, ABC is definitely it's 1 and then ACB because these two are different words. Take BAC, BCA, CAB, CBA. Likewise, so there are 6. Since it's a 3 distinct letters, I can arrange them in 3 factorial ways. Yes. With B, C, and D, we can form 6 different, likewise, all 6. Now, let's put into this way. So, each choice of 3 letters can be arranged 3 factorial ways. And we assume there are, say, X such choice sets. As I showed, ABC is one choice, BCD one choice, another choice, then ACD another choice. Likewise, we do have, let's say, X number of choices. So each choice of 3 letters can be arranged 3 factorial way that we have seen, which is 6. And let's say X number of choices. So using unitary methods, we can simply write it X such choice of 3 letters can be arranged X times 3 factorial ways. So here X is the number of choice and 3 factorial is the arrangement. And what do you know? Choice times arrangement is nothing but permutation. So X times 3 factorial is nothing but, as the problem is, I need to form 3-letter word, form all this A, B, C, D, E. So it is 5 P 3. By factorial by factorial, and this is number of choices times arrangement. Yes. Now, what we have to do, we have to find the number of choices. So we can simply solve these two to get x. I will remove this and write it on the top. So what we have seen, x into 3 factorial is 5 factorial by 2 factorial, which implies x is 5 factorial by 2 factorial into 3 factorial. So this is the number of, let's generalize this. Let's generalize. Assume I have n distinct letters and I need to form odd letter words. How many such odd letter words can be formed if we you know, go back to the previous problem and try to match these two? What we have seen, each choice of odd letters can be arranged, and we assume that there are x such choices. So x such choice of odd letter can be arranged in x times r factorial ways, and this is nothing but I need to arrange odd letter words from a set of n. So which is a permutation problem. If I simplify, which is n minus r factorial, and this is number of choices times arrangement, which is permutation. From these two, I can simply calculate the number of choices. X is nothing but n factorial by n minus r factorial times r factorial. So, which is, if you go back with this one, which is nothing but n choose r, because x is the number of choices, which is nothing but number of choices that I could make from n distinct object to form r distinct objects. So hope you like this derivation. I believe this derivation is very cool. You can try at your home. In case you have difficulties, you can inbox me. I'll respond to that. Thank you.